Dear students, let us investigate the second algorithm in addition and subtraction. So when the data is represented in 2's complement form, right? So when the data is represented in 2's complement form, how to perform addition and subtraction, right? So first let us see the case study for addition, right? So for this, in order to perform this, I am taking the example of 8-bit, right, precision. So in 8-bit, using 8-bit, I can represent the data with a range of maximum minus in 2's complement form minus 128 to plus 127. You know this, right? So this is important to know. So before proceeding any how many bit you are working on, this is important point. So for example, let us see the for the 2's complement addition first, right? So for example, 2's complement addition, I may have the numbers a and b, right? So again here I may get plus or minus a, okay? So plus or minus b, right? So let us see all the 4 cases, right? For example, suppose I want to do plus 6 plus 13, right? So you can observe, we'll get the result. So this is a decimal representation, you can understand this, right? Or I'll write like this is a decimal representation, the base 10, right? So same plus 6 can be represented in 8 bits, right? 0 0 0 0, right? 0 1 1 0. Similarly plus 13 can be represented 0 0 0 0, okay, 1 1 0 1. If we try to add these two numbers 1 1, right, 0 1 0 1, okay, 0 0 0 1. So this is 1, sorry, 0 0 0, right? This is a result. You can see that this is nothing but plus 19, right? So this is one case. So let us take one number as positive, right, another number as negative, right? So in this case you should get the result as minus 7, right? So now plus 6, you know how to represent plus 6 as it is. You can write like this 0 0 0 0. So 0 1 1 0. Now minus 13. So minus 13. So I know the plus 13 representation, this one. So this one I need to take the 2's complement, right, to represent the minus 13. How to take the 2's complement? First write the non-zero digit. So whenever you get the first this non-zero digits, so you start complementing, right? I told this how to do this, just directly can do, so 1 1 1 1, right? So then you perform the addition, right? You perform the addition, just you are taking the 2's complement of plus 13, right, for representing minus 13. 1 1 plus 1 0 1, carry, right, 1 plus 1 0 1, right? So 1 1 1 1 1. Now this is the result I got, but is this a minus 17? How I know that? So since it is minus, this is minus representation, you need to take the magnitude in 2's again you need to take the 2's complement of the result to interpret the magnitude. So this is minus, right, 2's complement of this number. Again how to take? So first write till the first one, right, non-zero digit, then you take the 2's complement of this 1 1 0, okay, 0 0 0 0. So this is nothing but this is equivalent to minus 7. So this is another case, okay. Similarly let us see another case, right? This is the second case, right? So let us see the another case, okay. For example, I want to do minus 6 plus 13, right? You get the result as plus 7, right? So what? So minus 6, so we know that plus 6 is nothing but 0 0 0 0 0 1 1 0. Now to get a minus 6 I need to take 2's complement of this. For that you write till the first non-zero digit as it is, right? So you go like this, first write the first till the first non-zero digit as it is, then from then on you take the 1's complement 0 1 1 1 1 1. This is what 2's complement of 6, right? 2's complement of plus 6, that is the representation of minus 6. Similarly you know plus 13, what is plus 13? Okay, 0 0 0 0 1 1 0 1, right? So then you add this, right? So 1 1 1 0 1 0 1, right, 0 1 0 1 0 1. If you get any ND carry, just ignore it. That's it. This is the plus 7. This is the representation of plus 7, right? So let us see the quickly the final case. For example, if I want to do minus 6 minus 13, so the result, you know, the minus 19. So you know that what is minus 6 1 1 1 1, okay, 1 0 1 0, right? Now similarly minus 13 1 1 1 1 0 0 1 1, right? So let us add these two numbers, right? 1 0 1 1 1, right? 0 1 1 1 1 1 1 1. You just ignore the end carry, right? So this is, since it is 1, you need to take the, this is a negative number, you need to take the negative. To find the magnitude, you take the 2's complement of this number. So how to get the 2's complement of that number? Just write 1, since the, right, 1 0 0, right, 1 0 0 0, right? This is nothing but minus 19, right? You can interpret this as a minus, right, 19 to the base 10, right? So this is 2 power 0, 2 power 1, 2 3, 2 power 4. So 16 plus 2 plus 1, this is 19, right? So minus sign, minus 19, right? So this is what the 4 cases of addition, right? So what we are doing in the addition, so just if there is any, if it is a positive number, represent as it is using the given number of bits, but if it is a negative, so you take the 2's complement of that number and represent, then perform addition, right? If there is any ND carry, if there is any ND carry, you just ignore that ND carry, right? So if there is any ND carry, you just ignore it, okay? So finally, that is one thing. So let me consolidate this. So what you want, what you are trying to do here, so if there is any negative number, you want to represent that negative number in 2's complement form and perform addition, right? So how to interpret the result? If the result is a negative, again you need to take, this is a negative number and you need to take the 2's complement to get the magnitude. That is one thing. Also if you get any ND carry, you just ignore it, right? So this is about the 2's complement addition, right? Similarly, in case of what to do, 2's complement subtraction. So let us take the any use case for 2's complement subtraction. Okay, for example, I want to do this 2's complement subtraction of, okay, minus 6 minus, okay, minus 13. So what to do here? So you know that the result is plus 7, right? But how to get this? So minus 6 first represent in the, so you know plus 6, right? What is plus 6? Plus 6 is nothing but 0 0 0 0, okay, 0 1 1 0. So how to get minus 6 out of it? You just to take 2's complement of it, 0 1 0 1, right, 1 1 1 1, okay. Similarly, you want plus minus 13, so first represent plus 13. So plus 13 is nothing but 0 0 0 0 1 1 0 1, right? So you need to take the 2's complement of it, 1, okay, 1 0 0 1 1 1 1, this is nothing but minus 13. Now you want to take the 2's complement, right? You want to take this 1 1 1 1 1 0 1 0 minus, okay, 1 1 1 1 0 0 1 1. You want to do this, right? So instead of subtraction, what I can do, I can take this 2's complement again and perform addition, right? So how to do this? So 1 1 1 1 1 0 1 0, I can take 2's complement of this, right? So what is 2's complement of it? First write 1 1, right? So then you write this 1 1, right? So sorry, you can write first this. So this is 0, right? So 1, this is 0 1 1, okay, 0 0 0 0. Then you can perform addition, right? So 1 1 1 0 1, right, 0 1, right, 0 1 0 1 0 right, 1, you can ignore that. So similarly, similar to addition, what I am telling here, if I want to perform subtraction, first represent the negative numbers in the 2's complement form. So instead of subtraction, so for example, if I take this number as a, right, if this take this number as b, right, so I want to represent a in 2's complement form and b in 2's complement form, right, then I can do this a plus b bar plus 1 to get the result, right. So this is the process behind this addition, 2's complement addition and subtraction. But here the important point is you want to detect the overflow, right. First of all, try to understand what is overflow here. So I told that using the 8-bit numbers, right, maximum bits you can magnitude in decimal you can represent minus 128 decimal to plus 127 decimal. But in case of overflow, you will get the out of range, or you may get the number greater than minus 1, less than minus 128, or you may get the number greater than plus 127. So this is the overflow. Like if you represent in a number line, this is 0. So you can represent, right, minus 128 to plus 127. But if you get a result within this range, okay, but if you get a result in this range or in this range, right, so this is called, right, overflow. This range is called overflow and this range is called overflow, right, overflow. So how to detect the overflow? There is a specific mechanism in this method to detect an overflow. For example, you do this plus 70 plus 80, you get a plus 150, right. So this is beyond the range, that is overflow. So you do this. So plus 70 is represented, I am writing 0 1 0 0 0 1 1 0. Similarly, plus 80 is represented 0 1 0 1 0 0 0 0. You perform addition 0 1 1 0 1 0 0 1 1, final carry is 0, right. Now see here, see the point is how to detect an overflow is you need to look into this carry, right, carry into the MSB, right, and you need to look into this carry out of the MSB, okay. So if those two bits are not equal, then that is an overflow, right. How to find the equality of these two bits? Just apply, right, this bit and this bit to an XOR gate, right. So this bit and this bit to an XOR gate, right. So okay, assume this is an XOR gate, right. So if I apply these two bits on XOR gate, if this bit is called overflow flag, generally we call it as V or OVF, whatever it may be, V or OVF, overflow flag. If this V equal to 1, meaning there is a overflow, means this carry bit carry into the MSB and carry out of the MSB, these both bits are not equal. So that is called overflow. This way we can detect the overflow. But what is the meaning of overflow? Actually in the overflow, how to avoid this overflow? By allocating the more number of bits. So here I am if I consider all these 9 bits, I may not get an overflow. But but here I am considering only 8 bit, right? So the result also 8 bit. If I get a more than 8 bit, that is a overflow, right? So how to avoid the overflow? Just to allocate the more number of bits for storing the result. But that is not possible in the fixed hardware, right? So that's why this must be properly detected, and accordingly you need to do it, right? So for example, you may take these cases, right? Here we do not get a overflow. For example, you take this case. Here there is no overflow, right or not? So why there is no overflow? This carry is 0, this carry is 0, both are equal. So no overflow. Here also this carry is 0, this carry is 0, no overflow, right? Similarly, you consider this case. Here this carry is 1, right? So you take this carry is 1, this carry is 1, both are equal, right? So no overflow. Here also this carry is 1, this carry is 1, both are equal, there is no overflow. So when we get overflow, if this carry both are not equal, these bits are not equal, then only we will get a overflow. So this is all about the basics behind this 2's complement addition and subtraction you should know. Then directly we can go to the algorithms, right? So in the algorithm is quite simple, right? What we are trying to do here? Okay, this is the hardware first of all. So this is a hardware. So what we do here? We do either, right, AC plus BR or, right, AC minus BR. How to do AC minus BR? AC plus BR bar plus 1. So that is accomplished by complementer and parallel adder, right? So then we have, if there is overflow detected, then OVF must be set to 1. If overflow is not detected, OVF must be set to 0, right? So let us go to the algorithm. So in case of addition, what is the thing, what are the steps required? So directly put one value in the AC, augment in the AC, added in the BR, just perform this micro operation AC plus BR, right? AC, if there is an overflow, right, so just set the overflow flag, that overflow, whatever that detecting mechanism, how to detect an overflow I told, right? So carry into the MSB, so carry into the MSB bit and carry out of the MSB bit, this 2 must be connected to the XOR gate, right? If this bit is 1, so that then this is a overflow bit, if there is a overflow, then that V flag must be set, right? Then so that's a simple addition. Similarly subtraction, what I told. So assume, so here also in case of addition I am assuming that, for example here I am doing AC plus BR, right? So I am assuming that if AC is a negative number, it's already there in the 2's complement form. Here also if BR is a negative number, it's already there in the 2's complement form, right? That I am assuming. Similarly in subtraction also, AC if it is a negative number, it is there in the 2's complement form. BR if it is a negative number, it's there in the 2's complement form. So assuming that AC minus BR, what I need to do, AC plus BR bar plus 1, and the result I store in the AC. So if there is, similarly I may get a overflow, if I get a overflow, just set the overflow flag. So this is the simple algorithm when the data is represented in the 2's complement form. Okay, thank you.